think of another part of the organization as the actual application of some of those models in specific components or specific verticals of the nuclear power arena. And that's where we believe we can create tens of millions of dollars of value for enterprises. We believe there's a tremendous amount of efficiencies that can be created by leveraging artificial intelligence. So we have a very strong conviction that we'll be able to build a sustainable company, and it's a win-win-win. It's a win for us, it's a win for our customers, and it's a win for society, because as we help nuclear become better, faster, cheaper, we enable us to battle climate change, enable us, USA to be energy independent from this technology that we've created. So we think it's a great story overall. We're super excited about it.
Just because the facts are A, if the narrative is B and everyone believes the narrative, then B is what matters. But it's our job in our industry to speak up proudly, soberly, and to engage people in this dialogue. Those 2.5 billion people that are in energy poverty, they need us.
America cannot meet this threat alone.
If there is a single country,
of course, the world cannot meet it without America,
that is willing to
but we're going to need you, the next generation, to finish the
overhaul
job.
nuclear regulation
We need scientists to design new
and
fuels.
focus on net public
We
benefit
need engineers to invent new technologies. We
over absurd levels of radiation
need
protection,
entrepreneurs to sell those technologies.
then we will march towards this.
We need workers to operate assembly lines that hum with high-tech,
we
zero-carbon
have
components.
unlimited prosperity for all humans.
We need diplomats and businessmen and women and Peace Corps volunteers to help developing nations skip past the dirty phase of development and transition to sustainable sources of energy. In other words, we need you.
Okay, welcome to another episode of the Fire to Fission podcast, where we talk about energy-dense fuels and how they can better human lives. My name is Mark Heineman, and today I'm joined by Trey Lauderdale, the founder and CEO of Atomic Canyon. Trey, how you doing, man?
Hey, Mark, good to hear from you. How are you doing today?
Excellent. I'm really excited for this conversation. We were bantering a little bit before the call started, and I can tell we're just going to get along. So, Trey, really excited to hear about kind of Atomic Canyon. You've done a bunch of podcasts already, which are awesome, and disclosed kind of what you guys are working on. But for folks that aren't podcast geeks like us, give us a little bit of background. Where'd you get your start?
Yeah, so great to be on. Atomic Canyon is an artificial intelligence company that focuses on bringing next generation technologies to the existing nuclear power fleet. So from our view, nuclear power is the key to the future of energy. It is the best potential source for us to have clean energy, abundant energy. And in order for us to achieve that, we really need to drive efficiencies in the way we build new nuclear power plants, the way we help current nuclear power plants run more efficiently. We believe the entire kind of supply chain of nuclear, from uranium mining, milling, refining, enrichment, fuel fabrication, existing plants, new plants, recycling. Artificial intelligence is like the computer has been reinvented. So from our perspective, there needs to be very thoughtful and pragmatic ways to apply artificial intelligence across the supply chain. So our company has set out with a mission to help be that trusted vendor to help do this. And it's been a ton of fun. We're 7 months old, so we're still, I'd say, early in our journey being in nuclear, but this space is incredibly exciting. And it feels like every day there's just a new announcement of whether it's new laws passing supporting nuclear, like the Advance Act, bipartisan support. I mean, in this day and age, what on earth has bipartisan support except for maybe nuclear power? So yeah, it's really exciting. We love this industry, and we think that nuclear plus AI is just a great place to be in right now.
Yeah. Well, 7 months as a software company, you guys are like sophomore status, right? I mean, as a nuclear company, that hasn't existed since, like 100 years ago, but
Yeah, no, well, that is true. It's I think the point that you bring up is very well founded, which is being in AI, things move very quickly. Like new models are coming out on a weekly, monthly basis, especially in this whole kind of cycle of large language models and generative AI. So you kind of have this one sector that moves incredibly fast. And then in nuclear, traditionally, as it should be. It is a very pragmatic, slow moving industry because we need to be very safe and we need to be very thoughtful about the way that nuclear technology is deployed. So there definitely is this almost like intersection of really fast moving technology plus a generally risk adverse industry. And as those two kind of come together, there is a lot of, kind of just feeling like you're getting turned back and forth.
Trey, why don't you give us a little bit of background on you? How'd you get into this?
Okay, well, I'll give you the shortened, abridged version because
Yeah, you've told other
we only
people,
want
but
to.
just for people
Yeah,
to get
yeah. So,
some perspective.
while we're new to the nuclear space, my background, my co-founder and I, Christian, who's an incredible AI technologist, we've done a lot of work in the healthcare IT, or as it's referred to now, digital health space. So back in 2008, I started a company, Volt. It was the first company that brought iPhones into hospitals for clinical communication. And when people hear that, I kind of get, turn their head and say, like, well, what do you mean iPhones in hospitals? Like, what else would people use? It's hard to remember, but back in 2008, the standard for communication devices, especially in the enterprise, was BlackBerry. Like everyone had Blackberries. And a lot of people would tell me, Trey, you're crazy. The iPhone will never be in a hospital. My nurses and doctors would never do video calls or view the electronic medical record on a mobile device. And, it was actually quite contrarian for us to say and bet on this mobile device or smartphone. To make a long story short, we were the leader in clinical communication. We put smartphones in the hands of hundreds of thousands of nurses and doctors, put a really robust infrastructure to let them communicate, receive mission critical alarms, did a lot of work with the FDA. And it was really just an amazing experience to see a new technology, which was the smartphone, enter a kind of more risk adverse, slow moving market, which was healthcare. And again, healthcare should be risk adverse because if there's a mistake in healthcare, someone could die. So that was a great experience, learned a tremendous amount about deploying technology to the enterprise. Eventually sold that company to a public hospital bed company named Hillrom. We got to run the digital group at Hillrom, a lot of digital transformation to make Hillrom more of a bed company to more of a technology company. We then sold Hillrom to Baxter for $10.5 billion. So a great, transaction that was very successful. After that, did a lot of angel investing, kind of fractional executive work, some work with venture capital and PE, all in digital health for a couple of years. And those past few years, it was all about artificial intelligence. And healthcare, I'd say, is definitely on more of the leading edge of applications of artificial intelligence. There's been a lot of work in digitizing health records, which has enabled kind of healthcare in general to apply AI in a lot of really advanced ways. So examples are helping a company that was supporting radiologists by enabling computer vision that help those radiologists maybe see cancer or other things that the human eye might miss. One of my favorite companies was leveraging automatic speech recognition to record a physician-patient encounter and automatically create that note for the doctor in the electronic medical record in a matter of minutes with like crazy accuracy, like 99% accuracy across 25 languages. So for me, that's when I really got to realize that artificial intelligence has gone from the R&D phase where it's kind of, hey, it's a cool project and PhDs are working on the science to no, we are ready to apply this in, again, a risk averse industry, which is healthcare, and really see material impact. I mean, there were physicians that would tell the company I used to work with, this artificial intelligence application has allowed me to stay in medicine. I'm getting 2 hours back a day. I can go home and spend time with my family. And healthcare means a lot. Like all of us have to engage in the healthcare system eventually. So we want applications like this out there. And you get to see that, this AI is real. Like it is going to have substantial impact upon humanity. So got to see a lot of firsthand AI applications. And you might say, okay, Trey, well, get to nuclear. Like, how'd you get into nuclear? 3 years ago, my wife and we moved to San Luis Obispo. And the house I'm in right now, we're actually 10 miles from a nuclear power plant, which is Diablo Canyon Nuclear Power Plant. So if you live in the proximity of a nuclear power plant and you're in a smaller community, which nuclear power plants tend to be in more smaller rural communities, They are a key foundational partner of the ecosystem. So people I meet everywhere work at the nuclear power plant, engineers. One of my favorite is my son's basketball coach was an engineering manager at Diablo Canyon. And I'm generally a curious person. So I'd ask people, nuclear sounds really interesting. Tell me about this. And they'd walk through the science of nuclear. And it really is a modern day miracle. I mean, the fact that we can split atoms and through that create heat, and we can use that heat to create clean energy. And the byproduct just sits in canisters, like it's right there. And we can actually recycle that byproduct, no carbon emission. It is a modern day miracle. So I was just incredibly fascinated to learn more about this incredible technology. But when I'd ask, so tell me about your IT systems, some of the computer programs that you're using, they would tend to laugh and almost kind of be like, oh, wow, well, let us show you what we got here. And you quickly realize nuclear power is this incredible technology, but there's been a tremendous amount of regulation. There's not necessarily the most advanced IT systems that are being used. So that's when it really dawned upon me that there is an opportunity here. And I started researching and seeing that the Biden administration has been very pro-nuclear. The Department of Energy has across the board put tons of initiatives in place to really reinvigorate our nuclear fleet. And there's almost this like excitement from multiple fronts where you've got on one side, it's national security, China and Russia and some of our foreign adversaries are expanding and building nuclear. And we as Americans need to make sure that we are the leaders in nuclear technology. And separately, there's the climate change opportunity where, look, climate change, we're starting to see the impacts of that. So you have this just bipartisan excitement and support for nuclear. So as I was seeing that and kind of pulling one and one together, it really dawned upon us that artificial intelligence has a key role to play in enabling and supporting the nuclear power expansion across the United States. So it's easy to come up with ideas and to talk about, concepts. I'm a big fan as an entrepreneur, you have to take action. And you could sit here and think and ponder and pontificate all day. What differentiates, just research from actual application is building. So I told my friend Christian, who eventually became the co-founder, we're going to get nuclear. This was around Thanksgiving. We need a data set. Let's go find one. So we kind of scoured the internet, did as much research as we could. We found the Nuclear Regulatory Commission's Adams database, a phenomenal source of open, publicly available data. We downloaded all of those documents, all 52 million pages. We then put together a series of kind of computer vision, optical character recognition, kind of fancy AI ways of saying we understood what was in all those documents. And then we launched a product, Neutron, totally free. We launched this in March, which is a way that enables any nuclear power plant, anyone who's in the nuclear industry, to search and find information on atoms in a more efficient format. And the problem to be solved here is the Nuclear Regulatory Commission and this Adams database, the interface that they have is a little bit cumbersome today to try to find information. So we wanted to leverage AI to make that really easy to
Cumbersome
search
is
and
putting
find.
it politely.
Oh no, well, I love my friends on the NRC. So I'm, what I'll say is there's opportunity for improvement. And I give the NRC a lot of credit because they digitize all these records. Like, so we could not build our AI if they hadn't gone through the process of taking the microfilm and putting it online. Look, it's a nuclear.
And it's
a
pretty
team
early
effort.
on that
We
they did
all
that,
got
right?
to
I
do
mean,
it.
some of these documents
Yeah,
are
yeah.
like from the 60s and 50s. Like, yeah, they're
Oh no,
digitization.
my friend. So my co-founder Christian, he loves this because if you think about really good engineers, what do they love? They love big, challenging, meaningful projects. So being able to get these documents that are from like the 60s or 70s, they're like typewriter documents, all of these acronyms, and be able to have computer vision actually understand what's in them, huge technology challenge. And Christian likes to share with me that the breakthroughs in AI and computer vision and everything else, what we're doing, we couldn't have done a year ago. That's how fast AI is moving. So it's super, super exciting. So we launched this product, Neutron, totally free. We've got tons of users on it. We're getting lots of feedback. The nuclear industry is some of the nicest people I've ever met in my entire life. Like they have been so welcoming across the board. We've made a ton of contacts, a lot of relationships. So from there, what we realized as we were building AI and nuclear is nuclear is really complicated, and the words that are used and the acronyms are really challenging for AI models to understand. So in order to solve this, everyone comes to us and says, Trey, build us a chat GPT for nuclear. And what we've explained to them is there's actually a missing piece of the puzzle here, which is you can't just go and use an open source LLM and build a chat GPT for nuclear. It hallucinates too much. And you hear the word hallucinate. That's us AI guys fancy way of saying it makes stuff up. So if you've ever used like a chat GPT or any of the large language models, you don't know if what it's saying is true or not. Like a lot of times it's accurate. It's getting better and better. But in many cases, it'll just like make up stuff that's wrong. So that is very bad. In nuclear, you cannot hallucinate. You cannot make things up. So to solve this problem, we realized that we actually needed to train the artificial intelligence to understand nuclear terminology. So to solve this problem, you need a supercomputer, you need a really powerful computer. So we went and we got connected with the Department of Energy, the Oak Ridge National Laboratory, and Frontier, which is the world's fastest supercomputer. It just so happened their team was looking to solve this same problem. So we were quickly allocated time on Frontier to use their computer to build out and train what's referred to as sentence embedding models. So this is actually training artificial intelligence to understand nuclear terminology. And we're actually going to open source this work because we believe the entire industry for free should have access to this technology, because we think there's going to need to be an army of AI developers building applications. And we want to really start to set the foundation and put foundational technologies in place to enable many players to enter this space. So that's really a lot of the work that we're doing now. It's a lot of learning. It's a lot of putting foundational AI components in place to really invite and try to pull many more AI developers into the nuclear space, because I think this is going to be one of the most important applications of AI is going to be to help nuclear power become more efficient, more cost effective, and ideally the preferred technology to help clean energy. So that was a lot. So let me know where you want to
all
take it from there.
Yeah, you've given the spiel before, I can tell, but that's okay.
Yeah. No, I get excited about it. I love what we're doing. It's I could not pick a better industry to be in right now.
Yeah. Well, why this supercomputer? Like, why do you need that versus training on like a different model? And I imagine that like helps set you guys apart a little bit, right? Being one of the first movers.
Yeah.
To the space.
So
Like,
when you
anytime you
look
got that,
at
it creates a little bit of a moat, right? But
Yeah. So when you look at artificial intelligence companies, you'll notice they tend to raise a lot of capital. Like they have to go and raise 10, 20, $30 million. And a lot of the rationale behind that large raise is to train specific models. You need a tremendous amount of GPUs, graphical processing units. So you need to go and purchase multiple NVIDIA H100s, or you need to partner with like a Microsoft or a Google. And that's expensive. If you raise the money as a VC backed company, you're giving up a ton of equity to go buy a bunch of computers. So from our perspective, the ability to leverage government resources and have a partnership with Oak Ridge National Laboratory, it really helps us, twofold. Number one, we don't need to go raise $10 million plus to build out these kind of clusters of supercomputers. So from a company perspective, and that enables us to retain more equity and more control over our future and our destiny. And then separately, Oak Ridge, as I'm sure you know, is one of the nation's premier research organizations. It's part of the Department of Energy's national laboratories. That group does some of the most advanced work on the planet in both nuclear and artificial intelligence. So beyond enabling us to have access to resources that would have been very expensive for us from an equity and venture capital perspective, we as a company get to husband our resources. We are extremely capital efficient because of this partnership. And then separately, we get the almost halo effect of Oak Ridge has hundreds, if not thousands, of companies that have come and want to work with them. The fact that they have selected us as a partner is a real testament, quite honestly, to my co-founder, Christian. He is a technological genius. And if he was here, he'd be blushing. But I always say he is a phenomenal genius. He's one of the best people I've ever met in artificial intelligence. And the fact that they've elected to work with him and our team is a testament. We are not, what some people say is like a wrapper on top of OpenAI, where there's nothing wrong with that, which is you're more of just the application itself of the artificial intelligence. We are a hardcore AI research and development shop. We roll up our sleeves and we build very advanced AI technology. So while we might not move as fast as some of the other kind of AI companies that are out there, what you will find is we are very pragmatic. We pick specific problems, we execute against those problems, and we solve real world applications of AI in nuclear. And this is a lot of the playbook that we used in healthcare, where you could come and you could say the smartphone, out the gates could solve all these problems and you can integrate all these advanced alarms. But really, you need to figure out a pragmatic, methodical methodology to introduce new technology in a very kind of risk conscious way, which is how you gain traction in a industry that is, life change or life critical and has the potential to have really positive or negative impacts. You have to be very, very smart in how you will deploy this technology. So a lot of what we're doing is leveraging a supercomputer to build artificial intelligence, which helps people use AI to just find documents. Like if you think about AI, it can be scary. Like sometimes I tell people I'm an AI in nuclear, and they'll say, Trey, that's the theme of Terminator. What are you doing? That sounds insane. So I have to really pull people back and say, well, the first thing we're going to do is use AI to help you find documents. You're like, okay, that sounds pretty, you're risk adverse. And then we prove ourselves. We prove that AI is reliable. It doesn't hallucinate when it's built by us. It works really well. And you earn that foundational level of trust, which then enables you to tackle the more complicated, robust, or riskier problems. So it's a very kind of stepwise process of applying new generation technology to kind of a risk adverse industry. So,
Trey, and so you talked about open sourcing this tool and being capitally efficient. I mean, I think that's brilliant, right? But the tool's also free right now. So while you guys are building the service and demonstrating capability, I mean, that's intelligent and also really helpful for folks. I'll say I really enjoy working with small software companies as a user, because it's more common that they're responsive, they give rapid feedback, they're willing to help you solve problems, and as you use their tool. And I mean, as a user of the Neutron tool, that's been my experience, certainly. How does it scale? What does it look like? How are you guys open sourcing this? And will that continue forever? Or is there, I guess, what's the kind of longer term strategy?
so from a go-to-market perspective, they're the first product we launched, Neutron, absolutely free. And I think part of that is we come at nuclear with a tremendous amount of humility. And we believe, as is important in nuclear, transparency is key. So a key part of our mission, vision, values is about transparency and honesty, because I think it is going to be incredibly important when dealing in nuclear power that you are as transparent and open as possible. So when we launch Neutron, we're very clear with the constituents that we engage with that we're new to nuclear. We're here to learn, and we think we're fast learners, and I think we made a ton of progress, but we still know that we're the new kids on the block in this space. So Neutron was our way of, number one, first giving back to the community and starting to demonstrate that artificial intelligence can be used in nuclear. Separate from that, from an open source perspective, the first models that we're building, we believe transparency is very important in artificial intelligence, especially when it comes to nuclear power. So we plan on open sourcing on Hugging Face the models themselves, the training data, all the information, so people can go and audit and ideally improve our models. That's the whole spirit of open source. Is you put the code out there, people use it, and you all together as a community improve the overall data set. And believe it or not, I like to say the Nuclear Regulatory Commission, whether this was intentional or not, the ethos and the spirit of open source is embedded within that organization. So if you think about the NRC and the Adams database, what is it? It is every nuclear power plant throughout the United States sharing information and sharing data publicly that's available to everyone else. So that is the exact same concept of open source technologies. So from our perspective, these first foundational models, we believe it's really important that we share those with the industry, we get feedback, and we believe the rising tide helps all boats float. From a go-to-market and monetization perspective, yes, we will eventually have to make money to grow the company, to raise capital, and to build a sustainable organization that can have the impact that we want to have across the nuclear industry and across society. So to enable that, we've had a number of discussions. We're not ready to announce anything, but there's a number of not only nuclear power plants, small modular reactors, the existing large reactor OEMs, consulting companies, you name it, that we've been engaged with, where we're taking parts of Neutron, what we built that's publicly available, we can deploy that in more of an enterprise format, whether that's on premise or in a private cloud. And there's applications that we're building on top of our Neutron platform that help create value for specific constituents and stakeholders in the nuclear power arena. And those are the products and services we will be charging for. So you can think of Neutron and the sentence embedding models as kind of the platform that we're building. We're open sourcing, big components of that, and we'll continue to keep the methodology and the spirit of open source in a lot of our foundational models that we're building. But then separately, think of another part of the organization as the actual application of some of those models in specific components or specific verticals of the nuclear power arena. And that's where we believe we can create tens of millions of dollars of value for enterprises. And we then cost share in some of those savings by helping organizations run more efficiently. We can then charge money and create a sustainable business model. So that's really been the go-to-market. And yeah, it's been super exciting. Like, this industry has been very, very receptive. We believe there's a tremendous amount of efficiencies that can be created by leveraging artificial intelligence. So we have a very strong conviction that we'll be able to build a sustainable company, and it's a win-win-win. It's a win for us, it's a win for our customers, and it's a win for society, because as we help nuclear become better, faster, cheaper, we enable us to battle climate change, enable us, USA to be energy independent from this technology that we've created. So we think it's a great story overall. We're super excited about it.
Yeah. You mentioned early on that you saw some of the IT systems in the nuclear plants, and they perhaps weren't as far along as some of the systems that you were used to implementing in hospitals and in healthcare. Were there like immediate parallels that you saw? Like, do you have an example of something that comes to mind that you're like, wow, we already did this in healthcare. Like, we could easily upgrade this for nuclear.
Yeah. So, I mean, well, not that we're starting here, but I chuckle because I used to tell people pagers, like the 1980 pagers. I used to tell people hospitals and doctors are the only ones that have pagers. Like, that's it. Like, that's the last industry. And lo and behold, I found nuclear where they still use pagers. So it's kind of
in the nuclear power plants.
We kind of get at it, right? We're like, our war against the pagers never seems to end. And here we found another industry that's got pagers. But, so we're not starting there. But I think it's definitely an indicator of an industry that might need some digital transformation is when you run into pagers. So that was we got a hoot out of that. But separately, where I kind of place nuclear power is if you flash back to healthcare. So healthcare, the real foundational technology that has really kind of enabled this whole healthcare IT digital transformation is the electronic medical record. So the EMR really didn't gain a tremendous amount of traction until there was the Meaningful Use Act, which happened in 2008, 2009, which it was part of the American Recovery and Reinvestment Act, which required all hospitals and all physician offices to transition to electronic medical records. The first, they used the carrot. If you did that, you could get, you'd actually get paid out from the government. So there was government subsidies to move you to the EMR. If you didn't do it after a few years, there was the stick. So carrot and stick. We actually got fined if you did not move to electronic medical records. So that became a big catalyst to enable Epic, Cerner, all of these electronic medical record companies to really become pervasive and enable the digital transformation of the healthcare industry. And you have people say on both sides. Some people say, "Oh God, that was brutal. Like, we shouldn't have done that. It caused us to like deploy these systems that we're not necessarily the best user interface. Other people have said it's been a huge success. I think, the truth's always somewhere in the middle, where it's good that we got the digital transformation. Maybe it could have been a different path to get there. But as a result, you had this digital transformation. So when the AI wave hit, there was all this foundational data that enabled artificial intelligence to get hold, and tremendous amounts of venture capital investment and private equity investment to really drive that industry forward. So I'd say nuclear is kind of in a space where, when you look, there is no equivalent of the electronic medical record or an operating system in the nuclear power space. There tends to be a number of what I'd say are like traditional ERP, enterprise resource planning services, like SAP and these other like big clunky systems that have been kind of customized, and you get like these big consultants that you pay way too much money to like customize these, like, I don't want to say legacy, but it's a lot of like 20-year-old products that are there. It's like you're a perfect example of like enterprise, slow moving products that really weren't built with the end user in mind. So when I see that, I believe there's tremendous opportunity across the entire supply chain. So I think I love the idea of starting with the current nuclear power fleet, like going in and saying, hey, we're going to leapfrog and we're going to bring the latest and most advanced technology to artificial intelligence. We're going to find these little crevices of where AI can be applied to just supercharge your organization. And we're going to do this as we build a platform that enables multiple modules of AI to be built and make the current nuclear power fleet super effective. But separately, when you look at like the construction of next generation reactors and the whole regulatory process to help get these reactors approved, get them built, there is going to need to be almost like a construction nuclear operating system as well that's built on AI. So I think there's huge potential, because in nuclear, everything is documented. And here's kind of like what I think is the key insight that I don't think everyone realizes yet. The fact that this industry has been forced to document everything means we have the best data source, I might say, on the planet as an industry. Nuclear is primed with tremendous amounts of data. What does AI need? You need a tremendous amount of data. So I don't think people realize yet, but artificial intelligence is going to absolutely transform nuclear power. Like, it is going to enable this industry to move way faster than ever expected. And it is my prediction, in the next 5 to 10 years, nuclear power as a segment will be the most advanced from an AI perspective. We have the data, we have the resources, and now that we suddenly are seeing the need, I mean, ironically, a lot of the energy is coming from AI itself. So you have this world where, Microsoft is saying we need to build a 5 gigawatt data center. It's like, holy crap, like 5 gigawatt data center, like that's like 5 AP1000s plugged into a data center. Like, that is insane. So you got like this huge need of power coming from AI, electric vehicles. So the fact that that power is going to then force us to figure out how to make nuclear more efficient, AI is the pathway to make nuclear more efficient, and then enable nuclear to help the data center. So it's almost like this really ironic, like circular relationship of AI, or nuclear needs AI to become more efficient, but AI is going to need nuclear if we're going to keep that exponential growth curve of training these like large language models and these other very energy consumptive kind of AI resources. So it's a super exciting time. Like, this little intersection, I didn't realize when I started the company how exciting it would be, but it's a blast. We love it.
So I was just listening to some today talking about data centers and how much of the industry, the existing industry data centers, are occupied with like AI versus just classic data center stuff, right? And like what data centers have enabled in the world. And like the example that was given on the podcast that I really liked was like Uber or ride hailing services did not exist and weren't even really conceptualized. I mean, they kind of were, but they kind of weren't. And I think when we have technological, you can say revolutions or step changes in technology like AI, I think it's difficult for people to wrap their minds around some of the like real benefits. So you've given the example. I mean, you guys have your platform and base that you're using right off the bat, but what does this look like for people within the nuclear industry? Can you give maybe another example of like the potential here and how it might impact in the future? Like, what does the workflow look like that could expedite and
Yeah.
create some of this value and allow people to do their jobs faster, or to have nuclear power plants operate more
Yeah.
cleanly?
Yeah.
Yeah.
So let's kind of blue sky this out a little bit. And again, when I say statements like this, I like to preface it by saying, I remember when I used to go in 2008 and tell nurses and doctors and hospital administrators, one day you are going to have an iPhone in the hands of each of your clinicians. And in that iPhone, a doctor will receive a notification about a patient, and they'll be able to hit a button and view that patient's medical record on the phone. They'll be able to view their real-time physiological monitor in an FDA approved format. So you will have streaming vitals near real time on a phone, and then you'll be able to tap a button and video call in with that patient who will have their own iPad or similar device in front of them, and you'll be able to see the patient in real time. Like, I say that today, and everyone's like, well, duh. Like, of course we could do that. Like, what else would we do? Like, that's very simple. Like, that's expected everywhere. In 2008, that sounded like witchcraft. It's like, Trey, you're insane. Like, what are you out there smoking? There is no way that would ever possibly happen.
On my
So,
BlackBerry, that's never going to happen. Yeah.
yeah, well, BlackBerry, that's one thing, but yeah, but like, you just couldn't even conceptualize how these devices, these mobile computers in your hand, how they are going to transform workflows. Like, you just couldn't conceptualize this because you never had the technology before. So when you look at artificial intelligence, there's a couple of things I need to say, because this is a different type of technological transformation. So the first thing is the technology is moving way faster than the smartphone. So I'd say when like the iPhone 1 came out, like, it was cool. Don't get me wrong. It was a really cool device, but it wasn't really until like iPhone 4, 5, 6 that it was just like unbelievable. Like, you had this app ecosystem, and they really figured out like the user experience, and then like everything. Like, it took like 4 or 5 years for like this to really be like an amazing device. With AI, like, you've seen like the 4 to 5 year of technological improvements condensed into like 4 or 5 months. It's like AI is changing really, really quickly. So that's important, number one, to recognize. If AI stopped today, I could do everything I'm about to describe to you. But AI is not going to stop. It keeps getting better and better. So that's just one thing to keep in mind, is we're going to be in this very challenging environment where the technology is going to be way more advanced than our ability to consume that as a risk-averse enterprise. So that's where companies like Atomic Canyon come in, is where all this like really advanced stuff is happening. How do we take it, make it reliable, and then actually apply it in a way that creates value for the enterprise? So let's give a couple examples. So, today you have a nuclear power plant that's operating, and they'll receive a request for information from the NRC. Maybe there's questions about the backup generators and the processes they're using, and the NRC will send a request for information. So what happens today is that at that nuclear power plant, there's a team of regulatory people that get that request and then say, okay, let's go first search all the NRC's website and try to find in Adams all the relevant information. It's almost like case law of how do we understand how others have responded to the NRC so we can get our response ready. It takes a couple of weeks of, a half dozen people searching NRC. Then internally, it's like, okay, let's go find all of our information that we're going to use to respond to that request. Then you got another team of people who can do their record management and all these documents and figure, we can't find this piece of information. And then they'll find that one person in engineering that's been there like 30 years that knows where everything is. And that person will get in and they'll find it. And so they then gather all this information and they put together a draft of what they were going to send back. And they review it. They bring in consultants, and those consultants review it. And then, 3 to 6 months later, they send their response back, and then it goes back and forth between NRC and nuclear power plant. So within the next few years, the way this is going to look is the NRC is going to send a request in that is going to get caught by the AI at the nuclear power plant. That AI, on behalf of the individuals, will search the entire NRC website. We'll find all the information on Adams of everything that's relevant. We'll gather all that information to help create the best potential template of how the response should look. Separately, there will be a separate AI agent that lives securely inside the enterprise behind the firewall of the nuclear power plant. And that AI agent will go search all their internal data, will understand what's the relevant data to place in that document, and the AI will create a first round draft. And it will point to all the documents that it recommended and that it pulled from to create this first round draft. So then the employees of the nuclear power plant won't spend their time hunting and searching and looking for data. They will get to spend their time doing what humans are way better at than AI, which is thinking critically and understanding how do we want to position this? What's the strategy? How we position this? What's the right information to share? So it enables humans to do what humans do best, which is think creatively and actually be thoughtful in their day to day versus searching and hunting and hiring consultants to go find data. So that world is coming, whether it's us at Atomic Canyon or others. That will be the way the world looks in the next few years. And the reason nuclear is so well positioned to do that is because we have this tremendous data set to train the AI models off of. So the idea of consolidating and collapsing these regulatory processes from months or years to like days and weeks, that sounds, when I tell people, far-fetched. It sounds like something that it's the equivalent of me telling people your iPhone will view FDA approved waveforms as a doctor. Like when I share like that, this is going to happen in AI, like the exact similar parallels there. You just have to be very thoughtful in how you integrate different components of this AI to find your way to that kind of true north of AI automation. So that's one example. And give others of, day-to-day work of what construction workers will be doing when we're building next generation nuclear power plants, or your current existing operators and maintenance crew. The idea of waking up in the morning, getting to work, putting on your Apple Vision Pro 6s, which will kind of look like sunglasses, and then going in, and those Apple Vision Pro 6s will have cameras built into it. So they will see everything that the person is seeing. And as that person goes through their day-to-day work and they're looking at a pump and they're doing their work order to change different components of that pump, their computer vision will be telling them, move this screw to the right, press this button. Oh, the light turned red. That means you need to go through process ABC. And then there'll be a microphone and speaker that will be telling them step by step what it is to do. And all of that will be powered by artificial intelligence. It'll enable the operation and the maintenance groups and the construction workers to move 3, 4, 5 times more efficiently. So when you think about the modalities of AI, a lot of what we've been talking about has been how do you figure out how to build a chat GPT for nuclear, or how do you streamline regulatory processes? From our perspective, this nuclear operating system, the way we've designed it and built it, is it's going to be multimodal. So we're going to start with the most risk-averse way of tackling AI and nuclear, which is all regulatory, which is taking and finding information. But our vision is a nuclear operating system which enables multiple modalities of AI, including computer vision, automatic speech recognition. And I think that's part of the value that we bring. Is we've touched on all of these different types of AI in our previous lives. So understanding how AI can be deployed across multiple modalities is a skill set that we bring to the industry, which we think is really unique. And I think it is going to be an incredible world. It is going to take time to get there. We're not just going to jump to this magically, but that's what we're excited about is, you go and you figure out what's the problem, how do we solve that problem with this new AI technology, and how do we make sure it drives value. That daisy chain of events is what we're really, really good at. So hopefully that gives you a couple ideas of where we're
No,
going.
I love that example. I think it's brilliant. And it really feels like the future. I'll comment.
Yeah,
Right?
future's
Like,
gonna be here faster than you know. It's gonna be.
well,
Yeah,
you gave
it's
like a
gonna be
knowledge
exciting.
worker example, and then you gave like a real life tangible, like, okay, well, here's a trade skilled worker that will actually benefit from technology advancement. And it's easy. I mean, as a technocrat, it's easy for me to see this progression, but I think people underestimate like how the progression happens, and it's like a continuous improvement. And like you said, it's focusing. Like innovation doesn't just jump to like robots doing the job and doing the welding on site, but it's one step at a time. You solve a small problem, and then okay, great, that's on the books. Then you go and solve the bigger problem, and the more people that are solving those problems along the way, and then sharing that knowledge, like that's how you get there. So I think there's awesome potential.
Yeah. Well, and like the parallel I love to give in healthcare, and again, I draw a lot from that because it's 15 years of my experience, but I think it's super, super relevant,
I
was
think it's
a
helpful to
mistake we
bring
made in
that outside
healthcare.
experience to other industries. I think it compounds and it's really
Oh,
productive.
yeah.
Yeah.
Well, an example I love to give is when we first brought iPhones into healthcare, we were naive. I was 25 years old, hadn't done this before. So I used to go tell nurses and doctors, hey, we're going to integrate all your mission critical alarms. We're going to enable text messaging. We're going to do all this out the gates. And the doctors and nurses would look at me and be like, are you crazy? We are not getting rid of this code blue pager. It's like when this pager goes off, we have to go save a life. There is no way we are trusting your smartphone with this pager's notification. And I was like, okay, lesson learned. So we pivot, and you very quickly realize the first foundational step is getting smartphones in the hands of nurses and doctors, and then enabling them just to send text messages, like literally a directory, and you can send someone a non critical text message. And lo and behold, they got huge value from that. And we got to learn, we got to realize, how do we make this reliable? What happens if the iPhone loses Wi-Fi? How do you have a backup plan? How do you have escalations for messages? Like, you learn all this information and then you improve that foundational tech. And then people gain confidence that the technology will work. And then from there, after we showed that text messages work, we built this directory. We then said, okay, we are now going to send that code blue notification to a smartphone, and you're still going to keep your pager. Like, we're not going to take away your pager. You're just going to get it twice. And that's how we're going to go live. And then when you go live with that, and then the first code blue that happens, everyone's smartphone like goes off in less than a second. You're like, everyone's like, oh, code blue, like a customized ringtone and everything. And then like 30 seconds later, you hear the pagers. And then that happens a couple of times. And then people quickly realize, you see a drawer full of pagers because people have then gained trust that the smartphone works. And you built all these like steps of extra reliability where if someone doesn't respond, it escalates to a backup caregiver. So a perfect example, when we start deploying AI in nuclear, we're not going to say the AI runs your nuclear power plant. That would be insane to go there. You start by saying the AI will gather your data for you, search and find, and then you show that it works. And then once you've built that reliability, you build the next level of trust, and you build the next level of trust. So it's a journey. It's a journey across all the modalities. And yeah, we're super excited. We got some phenomenal partners that we'll be announcing in the next few months, people that we're working with. And I think people are going to be really excited when they hear some of the progression that we've been working on the last few months.
Trey, this has been great. We're coming up on our time. Then I got two more questions for you, Trey. One of the things on our list was that every tech company might become an energy company ultimately, right? Like, this is where the nexus is going to end up. What are your thoughts on that?
Yeah. So when you think about big tech, when you think about like NVIDIA, Microsoft, Google, I think we as the nuclear industry are going to have an awakening that is going to occur, which is the magnitude of the size of some of these big tech companies is just like, it's very hard to comprehend. So let me give an example.
It's like country
Our good
size
friends in,
companies, right? Like,
oh yeah, no, like, no, it's like, oh no, no. Here's my favorite example. So NVIDIA. So if you know NVIDIA, they are the producers of the GPUs that almost everyone uses in AI. So NVIDIA, they're the ones, like, their stock has taken off. They were the world's most valuable company for a short period of time. Yeah, the other day, their stock gained 1% in value. So the stock went up 1%. The equivalent of that is roughly $75 billion, 75 with a B, $75 billion in market capitalization gain with 1% of NVIDIA. The largest provider of nuclear power in the United States is Constellation. Constellation has a wind fleet, they've got clean energy, and they also have, I think, something like 24 nuclear reactors. The market cap of Constellation, the last time I checked, is roughly $70 billion. So, like, let that sink in. A 1% shift in NVIDIA is the equivalent of Constellation energy. So, like, we as a nuclear industry, I don't think really understand, as AI, as Microsoft, as Google, as NVIDIA, as Meta, as these gargantuan $1 trillion plus companies continue to grow, like, what's their growth strategy? All of them are investing tens of billions of dollars in artificial intelligence because they see this is the next wave of growth. And they are all fighting to capture that next wave. So what has been the bottleneck to that wave? It has been access to GPUs. The supply chain was not ready to produce enough GPUs to keep up with the growth. That's starting to work itself out. You got other GPU providers coming in, Microsoft and Amazon, is everyone, they're all getting into GPUs themselves. They have thrown money to fix that problem because when the big tech machine moves, there's very few things that can get in its way. The next bottleneck, which we're already starting to see, is going to be energy. When you want to go build a 2, 3, 4 gigawatt data center, where on earth are you going to get that power from? So as that becomes the leading bottleneck, I think we are going to see actions from big tech that blow our mind. And it's funny, like you see big tech like making statements like, "Oh, well, we're not going to get into financing nuclear," and da da da. I won't say which companies have said that, but a couple of big tech companies have put a little bit of arms distance between them and nuclear. And it's so funny. Like, if you ever see NFL coaches or college football, I'm a big college football fan, and you have a college football coach who's like, "There's absolutely no way I am going to coach Ohio State, or I'm going to leave. I am so happy where I'm at," and da 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 da. And then like 2 days later, it's like, "I'm so thrilled to be announced as the head coach of Ohio State or of the Florida Gators." Like, it's like, they're not going to come out and say it, but look, when big tech has determined that they need energy and that is starting to affect the value of their company and their growth trajectory, there is going to be an unloading of tremendous amounts of capital. How does that unfold? I do not know, but my instinct is there is going to be some moves that happen in the nuclear power space that are just going to be tremendous. And these companies are all going to figure out in the next 3 to 5 years how they become energy companies, because energy will be the bottleneck, whether that's through joint ventures, whether that's through straight out acquisitions. These companies will solve this energy problem because they have the capital to do it. And it is going to be the problem that's in their way. And I think AI is going to play a big part of that. So we'll see how that all plays out. So that's my thesis is all the big tech companies within 5 years, they will all be energy companies, probably nuclear energy companies, but we'll see how it all plays out.
Well, we're lucky that we're recording this, so we can actually, hold you accountable on that prediction, right?
Yeah, no, that'll be fun. It'll be good. It'll be good.
Last question for you, Trey. How can people help? Looking forward, how do people help move and advance this to bring the industry forward?
So I'd say that when you look at the nuclear power space, we need more people. So there is
Literally
just
just human
the
capital. Like, we
existing.
need more people working on these
Yeah,
projects.
we need more. Like, everyone come on in. We need everyone to come this way. So when I look at this, again, drawing a parallel to healthcare IT, my previous industry, I remember in 2008 when I used to go try to get VC fundraising because I didn't have the resources to self-fund back then. When I used to go speak to venture capitalists and others, it was so funny. Like, they all would say, "Oh, we don't do healthcare IT. Like, we don't think there's money to be made there. It's not a great opportunity." All these, fancy investors on Sand Hill Road in Silicon Valley. And lo and behold, like 10 years later, every single one of them to the T has a digital health fund or a digital health thesis. Like, it is so funny how things have switched to like complete 180. In nuclear, like, nuclear is going to be the key to unlocking clean energy. It's going to be the key to keeping artificial intelligence moving forward. It is going to be the key to energy abundance of our society. So we need, number one, the entrepreneurs to enter this space. We need the technologists to enter this space. We need the funding to enter this space. And it'll all come. Like, this will all unfold as the market opportunity presents itself. And eventually you'll see one after the next. VC launched their nuclear energy fund, or they'll figure out some cute name for it, like their atomic energy or their fission fund. There'll be all sorts of that. But we need the entrepreneurs. We need more of the entrepreneurs entering this space. I, as a nuclear entrepreneur, will tell you I'll be the first one to field calls for new entrepreneurs coming in, giving you advice, helping you make connections. This is a warm and welcoming environment for those coming in. I think the current people that are in nuclear, stay as long as you can. The operators of the fleet, hold off your retirement a few more years. We need young people entering the plants from a construction standpoint. We're finishing Vogtle 3 and 4. As we look at new companies or new organizations that are building next generation reactors, we're going to need people in construction, supply chain. We as a society just need more people to enter nuclear. There's plenty of jobs. This is a growing space. So I say, come in. Like, I know it's scary leaving an industry and going into a new industry. I just personally did it. My investors who I had, who some of them put money in Atomic Canyon, some didn't. When I told them I'm going into nuclear 6 months ago, they were all like, or 7 months ago, they all said, Trey, are you crazy? Are you all right? Are you having a midlife crisis? And now it's funny, they're sending me articles saying, hey, you might be onto something here. This is an industry that you can learn. Come into it with a lot of humility. Come in saying, I know something about tech or I know something about construction. I want to learn nuclear, and you will find new resources abound. There are podcasts, Mark, like your podcast. There are people that are very welcoming. So I think the biggest message is, if you are new into your career, or even if you're, multiple decades into your career, if you're looking for a career change, nuclear is the place to be, and it's going to be a very exciting space over the next 5 to 10 years, if not 20 years, because look, maybe going full circle, there's very few bipartisan laws and bills getting passed. The Advance Act passed 88-2. Republicans, Democrats, everyone's agreeing nuclear is the path forward. So come into this space because we're about to see billions and billions of dollars of construction, of new projects. This is the place to be. So my message will be, come and join. I know it's kind of scary, like coming in, but there's a lot of great people here to guide. And any entrepreneur out there, if you're new to nuclear, I would love to take a call and help in any way I can. So that'd be the parting words.
Awesome. Trey Lauderdale couldn't end on a happier and more optimistic note than that. It's fantastic. Thanks so much for your time, man.
Of course, Mark. Thank you for all you do. Enjoy your time in Romania and around the world, and look forward to this podcast and reviewing your future podcasts that come out. So thanks for everything you do.